Okay, almost done with the 2019 exam one. Let's keep rocking. I will put in the documents so you can have your own copy. We didn't quite finish question 8, but the range of H, I mean, that wouldn't have been so bad. Fundamentally, you would have just been looking at the combined logarithm, like was suggested at some point last time, and then just sort of observing based on what it all simplifies down to. It's a positive log. All you got to do is worry about this as being basically the input to it, because you've got g of x involved, and you would just sort of figure out from top to bottom what those would have looked like. Maybe try those in your own time at some point, and let me know if that one needed any more clarification. Range of H shouldn't have been tough after this anyway, because you've already would have figured out your domain. But okay, that's that one. Question 9. State the rule of g of f of x.
E to the power of 3 plus 2x minus x squared.
E to the power g of, yeah, that's right, because you're shoving f into g. Yeah, you're right. So e to the power of all of that. Easy. Next up, find the values of x for which the derivative of that is negative. That also should be fairly okay. Maybe on the harder side.
Can we go over how to do a derivative of like e to the power of like a big function? I think it's chain rule, right? But
Yep. Yeah, it is chain rule. Yeah, it's not really here. It is just chain rule. So the chain rule equivalent for e to the x would be whatever's on the top is your u. So for chain rule, you want to get your u dash, and then y of u, and well, go from there. I can do it live if you want to, but I feel like with that you'd have enough to go off it.
oh no, could I just see you do it live?
Yeah, sure.
In chain rule.
Yeah, certainly. Let me just get the phone ready. Cool. Okay. Get our terms. So back to the actual question. G of f of x, that was, where is it? We had e to the 3 plus 2x minus x squared. Cool, that was that. We got to do derivative of this, so top is going to be u. U equals 3 plus 2x minus x squared. U dash, well, that's just going to be the derivative of a quadratic. 2 minus 2x. Y of u, yeah, let's fix that up. Y of u is therefore e to the u. Y dash of u is also therefore e to the u. And then, yeah, shove these two things together. 2 minus 2x, e to the u, which is 3 plus 2x minus x squared. That's our dy. Oops, can't write today for some reason. Dy on dx. So yeah, fairly standard chain rule. Maybe this bit was the weird bit because it kind of feels like you should have a different thing. But just got to keep in mind that exponentials pretty much always stay about as same as they can. So the basic form is always if you have e to the f of x, the derivative of that is f dash e to the f of x. That's what it always comes out to be. But the goal was not to find a derivative, although that will get you the first mark. It's to figure out over what domain is our derivative negative. Now that's a non-standard function. Plotting that would be challenging. So you have to kind of be good at observing what would it take to make this thing negative. Thinking about the components that make up the function. You've got an exponential term, you've got a linear term. Thinking about what it would take to make the whole thing negative.
You would either need a negative coefficient at the front, or you would need a y translation, which isn't there. So
Correct. Yeah, no y translation. You've got a plus 0 here, so the only way that would work is if the coefficient was negative. So that takes this fairly nasty question into something that's a lot easier to digest. Why doesn't this matter at all?
is it because an exponential is always positive? Like
Uh, yeah,
any ex doesn't matter what exponent you put it to, it's always going to be positive,
that's right.
somewhat positive.
Yeah. So if you think about like the extremes, a big positive number means this is a big number. A big negative number means it's a really, really small, close to 0 number, but still positive. And if you had 0, well, that's just 1. E to the 0 is 1. So no matter what you have, you're positive or 0. So the only thing that really matters is the coefficient, as you described, and that is trivial. That's just 2 minus 2x needs to be negative, so exactly less than 0. I mean, what are we talking about here? Fair enough.
Yeah.
Um, cool. State the rule of f of g of... Oh, the other way around. Yeah, okay. F of g of x.
Is it 3 plus 2 to the 2 e to the x minus e to the 2x?
Yes, those are all good. Absolutely. Yeah, just doing the opposite way around. Every x you replace with an e to the power of x. The only thing that might be slightly challenging there is how it behaves with the x squared. But yeah, that's just index laws. E to the x to the power of 2 can then condense down to e to the 2x, like you have. Easy. Next up. Solve for where this equals 0. So, easy start. Just make it equal 0. And we've seen a question like this before. Maybe multiple.
Is it x equal to natural log of 3?
X is equal to natural log of 3. Yeah, that was quite fast. Nice. What was the
Yeah,
overall?
I already started doing it whilst you explained the last question.
Nice. What was the approach there? How do you do it?
Well, first, well, we already had f of g of x, right? Which was
Yep.
negative e to the 2x plus 2e to the x plus 3
Mm-hmm.
equal to 0. And then you let a be e to the power of x.
Mm-hmm.
And then doing that, you'll get like negative a squared plus 2a plus 3 is equal to 0. And then you just solve as a quadratic.
Yep.
Solve as a quadratic, and then you resubstitute e to the x. And you'll have a positive and a negative solution, but e to
Mm-hmm.
the x can only be positive. And then you rearrange for x, which gives you natural log of 3.
That's it. Yeah. Perfect. Get your a equals those things. Therefore, e to the x equals those things. And then, yeah, natural log of that was x. For the quadratic, you could probably use a factorizing approach there. You would probably just multiply by -1 to make it a bit easier, but otherwise quadratic formula works perfectly fine. Yeah, speed. Find the coordinates of the stationary points of f of g of x. Yeah, okay. So remember, this is f of g of x. That's worth pointing out. I won't say more than that, just to be wary. Stationary points, so derivative is going to be important. Our very basic approach for stationary points is always going to be derivative equals 0. The reason I highlight this as f of g of x is because we haven't actually done the derivative of that one yet. We did the derivative of g of f, so don't feel tempted to use the derivative from part B. You do have to now find another one.
Chris, is the stationary point 0, 3?
0, 4 I've got.
Oh,
Let me
maybe I've
just
got a. Oh
quick.
yeah, never mind. I've got a addition error. Yeah,
Yeah,
my bad.
okay,
Should be
cool.
cool.
Yeah, so you did derivative 0, absolutely would have been the case. And then what from there? Was there any complications with rearranging that?
Uh, so there was two solutions of 0 and 1, and obviously the solution has to be more than 0. So e to the power of x is equal to 1, x is equal to 0, and then
Mhm.
you just put 0 back into f of g of x, and you should get 4.
Yeah, correct. If you shove your 0 back in there, you'll get it. Yeah, so let's maybe just quickly explore that on the screen share. I do have something kind of written up. Yeah, so there's what the derivative would have been like. Derivative equals 0. Solving via factorization, so e to the x equals 0 or 1 minus e to the x equals 0. That's where you would have had your two possibilities. Um, and then yeah, shove in, now that you know the x coordinate, the stationary point, back in to get the y. Cool. Back on where it should be. Part F, probably challenging. State the number of solutions to the addition of both composite functions being equal to 0. Um,
Chris, could you just write down g of f of x on the notes? Because I forgot what it was.
oh yeah, sure. G of f, let me remind myself, where did that come from? G of f was the answer to 9a, and the answer to 9a was... So, g f x was e to the 3 plus 2x minus x squared. And while I'm at it, I'll get fg of x, which was 3 plus 2ex minus e2x. So you want the addition of these two things to be equal to 0. You don't need to solve it though. You just need to give the number of solutions to it. Very tough question. Requires you to really understand some theory around what the graphs might look like. Actually had a decent pass rate, 19% pass rate. I was expecting a lot less, like single digits. Hmm. So basically, the addition of these two functions equaling 0 means that if you sketch the combination of the two, how many times does this have an x-axis intercept? That's the main thing you're looking for there. So the addition of the two, if we were just to sort of think about what that function will even look like, 3 plus 2e to the x minus e to the 2x, and then another plus of e to the 3 plus 2x minus x squared. That's the addition of the two. That is painful to try and sketch just on its own. Better off sketching the individual components very roughly. You don't need to like solve intercepts and stuff like that. Just very roughly knowing, okay, 2e to the x would look like this. Negative e to the 2x would look kind of like this. And then an addition of ordinates approach should push you in the right direction of how many times does the net result cross through the x-axis.
Is the answer gonna be 2?
Not 2 for this one, unfortunately. This one came out to be one solution here. What was your approach to get 2?
Well, I could see that the first three components wouldn't have an x-axis intercept.
They
Negative e
don't.
to the x wouldn't have one either.
Well, yeah, but you got to add the two together, remember? So
Right,
e to
and
the negative e to the 2x is going to decrease faster than 2e to the x would increase
okay,
because coefficients on the power is way more potent than a coefficient at the front. So like when you add these things together, like for instance out here, this plus that might actually come and touch this.
okay. No, I just thought there was something to do with the quadratic on the e to the 3 plus 2x minus x squared.
Definitely.
That,
Yeah, definitely.
yeah,
Because you've got to add
that,
that to this mix as well.
yeah, you know how like a quadratic has usually has two x intercepts?
Yeah, well, a quadratic has two x-intercepts, but that just means that's two spots where e goes to 1. Because remember, that just means 0's up here, e goes to
Oh, I
1.
see. Yeah.
So this exponential, like we explored before, never actually goes negative. This is just some positive always, but it might do a little bit of a wobbly. Because you would have had it before when you were solving the... In fact, did we ever solve this quadratic? Yeah, we solved it here, I think. 3 plus 2x minus x squared. Yeah, you solved it here. So whatever you got for here would have helped you with sketching the overall quadratic. And then you just got to remember that that's your new power. So it might go below, it might go above. So basically, the net result is probably something like this, where it because it's for a certain domain. Hang on, no, it's a negative quadratic. Let me think about this. So negative quadratics look like that, which means super negative means 0. then it peaks, and it goes back to 0. So it's going to do more or less something like that. It's going to look almost normal distribution type. Because as your exponent, like as x gets larger, this goes closer to negative infinity, and a big negative in the exponent means it gets closer to 0. Same thing on the left-hand side, up until some certain maxima. So you're going to have some sort of bump like that. How do you even analyze that? I had a lot to say about it. Let's see what I wrote. God knows how long ago. Okay, so here's all the components that matter. Let's see. Is it screen sharing? Yeah. Yeah. Okay. So here's all the components that matter. You've got the green, which is going to be the quadratic term, and you can see it does that sort of normal distribution kind of shape that we described, the green part there. You've got the blue, which is everything else, which probably isn't super helpful there, but the idea there is, you've got your 3, and that's going to be your asymptote. That should make sense, given that you've got exponential terms that could go to 0. And as we said before, the minus e to the 2x, because the 2 is in the coefficient of the x, that's going to decrease well and truly faster than a multiplier of 2 at the front, which is why the net overall would be, sure, it starts at 3, and even if you didn't get this bump, that's kind of fine. You just need to know that this shoots down negative at some point. And then the result of both of those is going to be, well, okay, this is 0 pretty much in most places, so it doesn't really contribute a whole lot until a very certain point. And so you can imagine you've got a lot of positive stuff going on from here. I mean, look, this is e to the power of a big number than just 2. So it's going to be more positive in that peak than it is negative for this bit. But because it decays quite rapidly, it is basically quadratic in that nature. This is going to well and truly become more negative. And you just sort of got to know that the net result of that is going to be that it only crosses over once. And I think a big part of that's going to be the fact that you've got an initial asymptote of 3. You're starting out here. It's a real tough question to get. But you can kind of get there. Like if you see what I sort of wrote on the handwritten bit, it describes in a bit more detail. It splits the 3 and the other 2 exponentials off rather than just having one combined one. You can kind of get the shape. I guess the debate would be whether it's like once or twice, because once is definite. Like if you get all these shapes down, you have absolute certainty that you're going to cross over at least once because it starts above the x-axis. So I guess the debate is whether or not there's a certain point in which it wobbles a little bit, and it kind of does, but it's up here. Tough. I don't really know how much else to describe there. Is there anything left to clarify on that? Definitely one of the separator ones with a surprisingly high. I feel like people just took a shot in the dark, to be honest, and just said, yep, 1, probably. Cool. Okay. And that's that. And that's the exam. Awesome. 2019 Tech Active. How are you guys doing with multis, by the way? Have you been doing the multi-choice sections in your own time? Are there any that you're starting to see are like worth looking at, or would you rather keep focusing on extendeds?
I mean, I don't really do exams right now because
Yeah, sure.
year 10. But
Yeah, that's fine. I mean, you're definitely doing
is
them.
multi just like same like level as extended response, or is it like easier?
Uh, um, I mean, we can quickly explore them just briefly, and then if there's any of you guys want me to like go into deeper, then we can do that. But some of them are fairly standard, like look, period range, that's whatever. Two real solutions, discriminant. Average rate of change, that's just a one equation thing. Evaluate an integral, that's just CAS immediately. F dash to F is an integral. Volume of box for maximum. Now we're starting to get into what feels more extended responsey, but they're doing it for a multi. When is the box maximized? You create your volume equation just like you would normally for this sort of stuff. F max, and then in fact that's going to be it. F max is going to give you the x coordinate for it. Mean, so this times that plus this times that. And the only thing you have to remember is that everything adds up to 1. So making that will get you a value, and then you do the whole this times that and add them all up. Conditional probability, bit of transformation stuff. That's the kind of things there. Any of those worth looking at, like little one-offs, or would you rather do the whole sequence of extendeds? Because some multis are challenging. It's just whether you'd prefer to
I
work
think
on. Yeah,
it'll be alright.
it'll be
Probably
right.
just extend response.
Yeah, because you just sort of treat them a bit differently. Like with the multis, it's kind of like you either get it or you don't, versus the extended response, you kind of have to now use previous information to then solve new questions. Multis obviously aren't going to have that because they're all self-contained. Where did I put my pen? Oh, it's over there. Anyway, cool. F dash, right off rip, that's going to be an easy one. Oh, right. Exam 2, let me put that in the chat for you. Minor, this is tech active, so we have CAS. That, or if you want to test yourself on the exponential chain, or you can. Minus 4 e to the x cubed. Not quite.
Okay, so I got 2x minus 2 times natural log of e times x cubed times e to the negative x squared.
Your CAS gave you natural log e, or did you do that by hand?
No, I don't know. Like, it gave me natural log e, but isn't that just
Yeah, that's just 1.
1?
I don't know why there's natural log e in there. Yeah, that's strange that the CAS gave you that. But yeah, I mean, that is right. You just want to get rid of it. And yeah, P, you got it as well. Minus 2x cubed e to the negative x squared. Yeah, all that's good. Just to be 100% transparent, this is what it looks like. Where is it? That. So yeah, very strange it did natural log e there. What CAS do you have?
Ti inspire.
Yeah, I did that.
Yeah, no, no. When I was reading it, I was like, no, no, this is like well, just chuck the natural log e in there. I'm like,
That's fun.
interesting.
I'm gonna play with that myself, see if it does the
Oh wait,
same
I think
thing.
I see what's happened. I didn't put the actual e in. Like I just like put it off the keyboard.
Yes, that'll do it.
Right.
Yeah, because that actually does. So if you are at all curious, like the rules for diffing e to the power of, where e is Euler's number, is different to diffing 2 to the power of or 3 to the power of. they are very different results. So if you just do like 2 to the power of x, you don't get the nice and easy, it stays as 2 to the power of x. You get natural log of 2 out the front. As for why you get that, I can't really answer that. I didn't really look into it that much detail, but you can basically surmise that you just natural log the base at the front and then do chain rule like you normally would. I would expect, anyway. In fact, yeah, I wonder if that'll maintain if I put like an X here. Nah, okay, then it all goes to shit. That's fine. Let's just leave that there. Yeah, cool. Nature of stationary point. This should also be very easy. We have CAS, we have practically everything we could ever want. Just got to be using the right terminology, I suppose. What does it mean, nature of stationary point?
Is it a local minimum?
Local minimum. Yeah, that's it. Did you graph it on CAS or otherwise?
I mean, I did graph it on CAS, but I guess there's a approach that you can like do like x is equal to 0 and then do like points nearby.
Yeah, yeah, that's also fine. Yeah, testing x equals 0, x equals 1, x equals -1, which oddly enough would have actually made both the min and max. You would have found them all just sort of by doing that. So I guess that is a bit risky. If it's a quite changing graph, then you'd want to choose points really close by, like 0.01, -0.01, just to be really sure, but that's kind of being a bit overly cautious. But it just sort of goes to show if you do have a drastically changing graph, you may actually find points that are below somehow. So yeah, sketching is the safest by far. Or even just nah, FMin wouldn't be particularly helpful. In this case, I would have got it, but as a general rule of thumb, you probably wouldn't FMin that. Because FMin doesn't really find stationary points. Neither does Fmax. It finds the actual max or min, whether it's a stationary point or not. Double I mean, yeah, nothing to really talk about there. It's on the graph. You can just look at that. That will just move to triple I. Find the values of D for which f of x plus D is always negative. Yeah, that'll be worth basically discussing. F of x plus D. These are vertical translations since it's a plus at the very back of the function. And so for f of x plus d to be negative, it basically means you want to force all the y values to be negative, right? Like the net result y after you have f of x plus d should always be a negative number. Even though we didn't do it, the answer to the previous question would have been quite helpful to this, but yeah.
Is it gonna be one on E, non-inclusive to, I mean, basically infinity?
Okay. Um, those are both positive numbers, though, is the thing. So that would
Oh,
mean
sorry. Oh,
shifting it.
my bad. Negative one on E.
Yeah, that's better.
Oh, wait. Yeah, yeah. But it'll be ne wouldn't it be negative infinity to negative one on E
Yeah, just flipping both of those. Correct.
and both non-inclusive?
Both non-inclusive. Yeah, correct. Because exactly one on E was going to be whatever the peak was there. So if you actually solve the maximas there, you'd find about 1, negative 1, and about 1 over E. And so if you want to make the whole graph function negative, it means having it entirely below the x-axis, not above. And so exactly 1 on E would make them equal. We want negative, not 0. And so yeah, anything to the effect of d less than negative 1 over e, or you can use your rounded brackets of infinities, the interval notation. That's fine. Let's see, equation of tangent, that's free. You'll need it for double I anyway, so we might as well quickly go through it. You will need it. This one's a CAS instant solve, whether you have Casio or T-Spa.
Um, is it just zero?
Um,
Y is equal to, I mean,
Gradient 0.
sorry,
Yeah.
the gradient is zero, but is it Y is equal to one on E?
Y is equal to 1 on E is better. Yeah.
Yeah, my bad.
Yeah, I think you just got it mixed up between whether it's gradient 0 or, yeah.
Yeah.
Because you got 0x plus 1 over e. Yeah, I mean, you didn't even need the CAS for that one, actually, now that you mention it, because, yeah, if you understood that you were taking it at a turning point, then, yeah, you have a flat line there. You just need to know what the y value is at that spot, because you'd be taking it, like, here. Now, technically, you're taking it up here, but yeah. How can you do it? Well, if you don't recognize that, you also got tangent line. Just give f of x comma negative 1. Exact same thing for the Casio. Cool. Double I, find the area enclosed by f and the tangent. So there's the only two things that are mentioned that are bounding, creating the bound area. And it's to 4 decimal places. That opens up the solution space. We can also use our graphing tools if we wish, although it can be a bit janky to play with. Get a fair bit of freedom as to how you want to solve it. Bound area is always going to be a top take bottom scenario. Integral of top take bottom. So one of the first things you want to do is figure out what's top and what's bottom. The other thing you want to figure out would be over what domain are we integrating? integral, of course, being area under curve. If it's not immediately obvious which one's on top of the other, you have your graphing tool to help you out.
Yeah, but Chris, like, could you show on like a piece of paper like how the enclosed will look?
Yeah,
Because I'm a little bit confused.
I can do you one better. I can just show you exactly. So if you have a look at the screen share, you've got the graph of y equals 1 over e. You've got the graph of f of x. What's bound between them is this.
Okay, okay.
So the way to think about it would be obviously plot both on the CAS, and then the graphs that are mentioned, you got to think of as the perimeter of your shape. So you got to use those to trace your finger around and figure out, okay, what creates a fully enclosed shape? That's the thing we're looking for. There's no way to enclose a shape outside of that domain, and so you only do the middle bit.
I got 0.3568.
That will do it. Yeah, 0.5. Oh, 3568. Yeah. Yeah. Integrating from -1 to 1, since that's the horizontal span. The blue 1 over e is of course above the green f of x, and so we do 1 over e minus f of x. Nice. M is some random point on the graph between 0 and 1, in the x direction anyway. Find the minimum distance between this point and a fixed point, 0, e, and the value of m for which that occurs. So, whether they say this or this, you're still doing the exact same procedure. They're getting you to do both. Minimum distance, maximum area, maximum value. All of these things have the exact same approach to them.
Do we set up a distance equation?
Absolutely. The first stage for all of these questions, you're trying to maximize or minimize a thing, you need to have an equation that describes that thing. Normally you would do your area equation, your volume equation. Here we're getting a distance equation. The only thing I'll say for this is when it's tech active, you have to be slightly worried about the fact that the minimum distance or maximum distance may or may not be a turning point. So typically relying on Fmax and Fmin is a bit safer because I have seen at least one circumstance in a tech active where it wasn't a turning point. That'll never happen in a tech free, otherwise they're really stuffing you over because if they give you a complicated function like this and tell you, hey, give me max, it's like, yeah, sure, good luck with that. You have to assume derivative zero. And, that'll carry you through most questions by far. I think I only recognize or remember one specific scenario where it wasn't a turning point. But that's enough to say, hey, probably rely on f min rather than your derivative zero here. But to catch us all up, this is what the distance equation should end up simplifying down to. Now the CAS may or may not say that's what it is when it simplifies itself, but you are just doing difference of x values, difference of y values, all squared, and then all rooted. You're just doing Pythag basically, and you're expecting something like this, the blue line. This is me just eyeballing it. This isn't the exact spot, but yeah. Sometimes it can be a bit complicated shoving in points into the geometry style stuff when you've got your y2, y1, x2, x1. It can be good in your working out to literally label the point. This is x1, this is y1, this is, well, I guess I didn't really label the point here, but the next one would be x2, y2. You'd literally write it on top so you know exactly where the terms are going. Makes it harder to get it back to front. It's less of a problem with distance equations because even if you do, like as long as you know that x's are x's and y's are y's, even if you do somehow do them back to front, because you're squaring it, it goes back to being positive anyway. So it's one of the ones where you can't really mess it up too hard. You just need to know the equation and put x's with x's, y's with y's. I wonder if that restriction of 0 to 1 actually matters. It kind of feels like the graph is just going to plateau again. Oh, wait, maybe it matters because of the back half of this. No. Maybe. It kind of feels like that's going to be the minimum regardless. Unless this shoots up somehow, but I don't think it should. Anyone stuck? Or still just working through the question? Kaz crashed. Uh-oh. Kaz crashed on what? What would crash it? Probably not diff. Maybe it's just a random tech issue.
When I put the min thing in, it crashed.
Fmin.
Yeah.
Ah, okay. Um, yeah, I don't know. Weird. But yeah, look, you got fmin, you got derivative zero. Another thing you can do that definitely shouldn't crash it would just be, hey, you've got your distance equation. Just plot it over the domain that you're allowed to plot it, and then use the graphing tool to grab the coordinate. That's probably the. They're all about the same speed. Fmin, if it doesn't crash, should be fastest, but apparently this is a bit of a complicated one. I didn't actually test fmin for this, so maybe it does just crash it, which would be unfortunate because it doesn't look too complicated a graph. But yeah, anyway, all those options you have. Just remember you got to give both the x and the y, where the x is going to be the m coordinate. So that's the point on f. So that'll be this spot here, x, and the y is the actual distance because it's a distance graph. So it's going to be this blue length. And yeah, giving both to 3 decimal places. These should be good. Question 2. Find diff. You'll maybe need it. I guess you could use it for B as well. I'm happy to skip A since it's just a CAS plugin. If you want to go straight to B, happy for you to do that.
Hey, Chris, I don't know if you've experienced this, but like my CAS like a non-stop loading circle.
Oh, okay, it's still doing it.
Yeah, so is
Pull
there anything I can
the
do in this situation or
yeah,
just
pull the shield off and then pinprick that reset button.
uh
Yeah, so pretty much if you've ever taken like more than 30 seconds on a thing. Now, just keep in mind it does reset it to not factory settings, but if you're the kind of person that saves documents, if you've left it unsaved, that'll get rid of it. It shouldn't reset defaults though.
no, it's okay. I only use it anyways.
Okay.
I said I only use Scratchpad, so it should be okay.
Oh, sure. Yeah. I will give a warning for part B actually. Oh, hang on. That'll be 0 to 20. 0 to 20. Not quite 0 to 20. We're looking for gradient strictly decreasing. So that means where is the slope of this graph always going down, basically. 0 to 20, you would have an up part and a down part. You're looking for just the down part. Yeah, gradient graph, correct. That's one way of doing it. You could do diff and then um, diff being. Oh, sorry. Yes, no, gradient is decreasing because even though it's positive gradient, it's getting smaller. No, sorry, you're right. Yeah, 0 to 20 because that's the inflection point. Yes, sorry. I should have actually looked at my notes instead of just spouting bullshit. Yeah, 0 to 20 is correct. Sorry. Only thing I'll highlight there to give some additional guidance there that's actually correct is you want to exclude the 0 there. And that's simply because it's an endpoint. You can't be differentiable at endpoints, which is why you exclude the 0 from that domain. But you can include 20 because it's part of the overall domain. Or part of the. There's a value immediately before and after it. Yeah, good for calling me out on that one. Nice. What have we got here? A cable connected up here. Basically, this dotted line is your cable. There is a straight line, so a linear, connecting the y-intercept and this point A comma B. And from then on, it just follows the natural curve of the hill identically. State the rule of the cable from A to 30. F of x plus 3, yes. Yeah, it's purely vertically translated up by 3, so it doesn't even matter what A is, we just know that from A and onwards, it's shifted up by 3. And so yeah, f of x plus 3, so you would say, well yeah, h of x is that plus 3. Nice. Part D, values of x for which the gradient of the cable is equal to the average gradient of the hill. So gradient of cable, like specific spots on the cable, equal to average gradient of the hill. Playing with two separate concepts there, and then making them equal each other. The x values are going to come out as a bit nasty. You're going to have some roots in them. So if you just want to type out plus minus some roots, feel free. And I can just pull it up rather than you have to type out the whole thing.
Would it be 60 plus minus 10 root 3 on 3?
That's exactly what it is. Yeah, really good. Yeah, two components to that. I can't imagine any other way of doing it. You would do your average rate of change for the domain associated with it, and that tells you what to make your diff equal to. Sweet. Did you have any other way of doing that? I can't really imagine any other.
No, I did it that way.
Easy. Cool. Let's see, can we get one more of these done? Yeah, I reckon we might be able to bash out EI in a minute. What do you think? Gradients of the straight and curved sections approach the same value at x equals a. So there's a continuous and smooth join at a. So gradient from left is equal to gradient from right at this crossover spot. State the gradient at that spot purely in terms of a. Got to figure out a way to get a into the equation. If you need to be somewhere, just let me know, by the way. We get time. I'm not going to try and keep you for nothing.
Would it be just the derivative we found before and then just sub a into the x place?
Yeah, exactly. H dash a. Nice. Done deal. Cool. All right. If you're in the flow of things, it would be decent to probably finish those off. There's only two more questions for the chapter for the question there. So at least that way you can start fresh on the next one. Anything left to clarify?
No, all good. Thank you.
Easy. Best of luck. Take care.